Alright, so our next example is asking us to write an equation for the parabola with focus at 2, 2. As soon as I start reading this, I tend to make a little sketch for myself to get my thoughts together. So the focus is at 2, 2. And the vertex is at negative 1, 2. All right, so since it gave me the vertex, I know what my h and k are for my equation. What I need to do is make a couple of decisions about how to proceed. First of all, with the location of the vertex and focus, the focus has to be inside of the parabola. So the parabola is going to have to open to the right. And that means that this is a y squared situation. So once I've made that decision, I can then look at where the vertex and focus are and count how far that is away. So from the vertex to the focus, I'm moving to the right, so it's a positive number, and I'm moving 3 places. So C is 3. So since the vertex is at negative 1, 2, I think I'm ready to begin. Y minus 2 quantity squared equals 4 times C, which is 3 in this problem, times the quantity x minus negative 1, which we'll write as plus 1. Simplifying so that this is in the standard form for a parabola, we get the equation that I'm writing right now: y minus 2 quantity squared equals 12 times the quantity x plus 1. All right, for the next one, we're supposed to graph the given equation. So let me write that down. All right, so this is obviously a y squared kind of problem. If you look at the answer above, that's sort of what our answer needs to look like. So I know I'm going to need to complete the square for y. To start, I'm going to move any constant that I see on the right, like that negative 3, over to the other side. And the coefficient of y squared must be positive 1, and so I'm going to factor off the negative 2, which leaves y squared minus 2y. So completing the square, I'll leave myself some room to do that. Minus 2y. All right, so complete the square. Now the coefficient of y squared is 1, we can do that. Half of negative 2 is negative 1. The square of negative 1 is positive 1, so I'm adding 1 inside the parentheses. Notice that outside the parentheses there's a multiplication by negative 2, so on the other side I'm going to have to add negative 2 times 1 to keep the balance of that equation. If you were to distribute on the right side, that's what you actually added when you added 1, was you added negative 2 times 1, or subtracted 2 times 1. Either way to say that is correct. All right, so doing the arithmetic, that'll become x plus 1 equals negative 2 times the quantity y minus 1 quantity squared. And then the very last step is that the squared part of the equation has to be by itself. That negative 2 coefficient cannot stay there. So what I'm going to have to do is I'm going to have to multiply both sides of the equation by negative 1/2. That's the reciprocal of the constant on the other side, to turn that negative 2 into a positive 1 in front of y minus 1 quantity squared. Okay, so that's the answer to that example. Then we're supposed to graph that, and as well we're supposed to give the domain and range. Almost skipped doing that accidentally. All right, so from the work that we've done, we should write down what the vertex is. Its coordinates are, for this problem, -1, 1. And for C is equal to -1/2. Dividing both sides by 4, we find out that C is equal to -1/8. This one's going to be a little bit more challenging to graph because of the small value of C. So it adds a little challenge to it. So we're going to be doing some estimating to make this look correct. So let's get this all set up. Don't forget to label your axes every time. Okay, so I'm going to, since C is really small, you might notice that my marks on the axis are a little bit further apart than I use sometimes, because we're going to be estimating that distance of 1/8 in the negative direction to get to the focus from the vertex. Okay, so now that that's all set up, let's plot the vertex at -1, 1. That's it right there. Then I'm going to move either down or left because C is negative. Now, which way is it going to be? Well, since Y is the thing that's squared, that means that it will open left or right. Since C is negative, that's to the left. So move from your vertex 1/8 to the left, and then go 1/8 to the right to plot your directrix. Now see, these numbers are so small, it's really hard to make this look right, but we'll do the best we can. All right, then if we double C, that's 1/4. 1/8 times 2 is 1/4. So from the focus, we're going to move up, parallel to the directrix, up 1/4 and down 1/4. So let me change the color here. Up 1/4 and down 1/4. And then sketch the curve. Now you notice that I'm going through the x-axis at some random point, and there's no way I'm going to get that perfectly correct with my graphing unless I actually calculate the x-intercept, which this problem doesn't ask us to do. As it turns out, it's -3, but that's not absolutely necessary for you to get correct here. Just do your best when graphing. All right, so the last part of this question was, well, what's the domain? Since the graph goes off to the left forever, we're going from -∞ up to the x-coordinate of our vertex. So that's -1. And we stop there, and it's included, so we put a bracket. The range, well, this parabola is eventually going to go down forever and up forever. So the range is all real numbers, which we write as the range is the interval notation -∞ to infinity. Okay, let's see. The next example has to do with an application of parabolas. I'm trying to move this screen. There ought to be a little bit faster way to make that happen. That was too fast. Oops. Okay, well, back to my slow method. Sorry about that, folks. Just takes a little bit of time to move that little thing up there. All right, that's probably far enough. Now, the Parkes Radio Telescope has a parabolic dish shape with a diameter of 210 feet, as you see in the picture, and a depth of 32 feet. Because of this parabolic shape, distant rays hitting the dish are reflected directly toward the focus. All right, very, very good. So, since this is a physical object, it's actually in our control as to how we draw that. So I kind of like the way they drew it, kind of opening straight upward. In reality, they probably are tilted to various angles, but this is good for us. And so I think we'll be able to find everything we need if we allow for this parabola to be drawn opening upward. And because it's my choice, I'm going to make the vertex at the origin. Okay. Now that's only part of a parabola. We're going to pretend like it goes on, but we're going to stop it, and there we go. There we have our dish-looking thing. Now, to use the 210 feet, realize that from the this edge to the far edge is the 210 feet. So that means that because our vertex is at the origin and because this is a symmetric figure, half of that distance is on either side. So that's at 105 and negative 105 for the x-coordinates of those ending points. Let me put dots where those are, where I'm considering that to be. Okay, and then because of the 32, that's going to make this at a level of 32. This point has coordinates 105, 32, for example. Now, that's below the focus, so we can't assume that we know what the C value is. If that line, the 210-foot line, were going through the focus, we could use the fact that from the focus to either of those points is 2C and go forward from there. But that's not what's given. These are random points. The focus is up here someplace. I'll exaggerate it, I guess, and put it like up here someplace. So we're not able to figure out, what the distance to C would be to either side. So that's not going to help us. Now, what will help us is the fact that it is upward pointing. So that means that because of that, we're going to be using the idea that x is the variable that's squared. And our vertex being 0, 0 makes this x squared equals 4 times unknown c times y. So that's x minus 0 squared equals 4c times the quantity y minus 0. And because we know that the one point on this has coordinates 105, 32, I can substitute that into the equation I have so far. 105 squared will equal 4c times 32. Oops, made a stray mark there. Doing the arithmetic and solving for C, you should get that C is 11,025 over 128. So, putting that together with the equation we started with means that x squared is equal to 4 times our 11,025 divided by 128 times y. And simplifying the numbers that are in this problem, this ends up being x squared is equal to 11,025 divided by 32. That fraction is multiplied by y. And that completes that example. All right, so this was part A to find that equation. So we finished that. In part B, I guess I should have labeled this part A. And this will be part B. If we wanted to find out where the focus is, when we found C, that's how far we're moving from the vertex, in this case upward, to get to that focus. So we're going to start at 0, 0 and move up 11,025 over 128 to get to the focus. Now, since this is kind of a real world problem, a lot of times the decimal form of that number will seem better. So that would round to about 86.1. So the focus should be located sorry, all of a sudden the pen's not working great. The focus should be located about 86.1 feet above the vertex. Okay, so that ends this lesson. In class, we'll go over any questions you guys have about this material, and appreciate your attention. Have a good day.